Welcome to Never Rewrite. I'm Isaac Askew.
And I'm Jeffrey Sherman. And today we're going to discuss Project Risk.
Hmm.
A few episodes ago, we had special guests Nathan Keys and Colleen Grafton on. And near the end of the episode, Nathan and I got into a conversation a bit where he was talking about how he had structured the rewrite project to minimize risk throughout the life of the project.
Right.
And in retrospect, the company seemed to have wanted him to do more of structure it so that there was customer value throughout the project instead of customer value at the end.
Hmm.
And I had an initial undefined but negative reaction, visceral negative reaction to when Nathan said that he was structuring the project to minimize risk. And I didn't know what it was. So I
Okay.
had to go away and think about it. But I had this initial you're wrong. But I wasn't going to shit post and say you're wrong, and I that will no follow up because I'm like, hmm.
He's our
So
guest.
and plus he's
He's
our
right.
guest. Well, he's not necessarily right, but we should definitely be polite to guests. But
Okay,
he
well,
wasn't
where is he
necessarily
wrong?
wrong either. And so what I was thinking about it was the thing that he was wrong about was that he actually made an enormous, very risky assumption or decision right up at the front, which was he had
Okay.
decided to rewrite. When
Hmm.
you by starting a rewrite, you've now made the very risky or assumption decision that a rewrite is going to work, it's going to be better, uh, and that it's going to succeed. And those are all very risky things. And so every incremental thing, it might seem like, okay, now that I'm doing the rewrite, I'm going to do this little not so risky thing, and then this not so risky thing, and then this not so risky thing,
But they're all
and
in the
then I'll
back of a big risky thing.
right. You've already bet on the entire project, and it took me a while to figure out that that's what I was reacting to. This idea of when you start a rewrite, you're making a massive bet on a rewrite. It doesn't matter how risky any individual component is because you've got this
Yeah.
massive. The rewrite must succeed or you fail. So, with that said, I wanted to flip it around and say, okay, but how is iterative or thesis shipping, as I am trying to make it a thing,
Branding it by the
branding
domain
it,
name.
ship it. How is that less risky? And going, playing with some of the ideas that we had. And the first thing I came up with is when you're iteratively replacing something, well, one of the first steps that we talked about is you need to understand the system, right? You need to understand the system well enough to replace it. And this is true whether you're iteratively replacing it or you're going to do a full rewrite.
Hmm.
And we talked in one of the episodes about how when you do a full rewrite, it often is an excuse to not understand the domain and an excuse not to do it until so you end up doing all that stuff at the end. Because first you need to build the framework so you can build the thing. If you instead front load and say, whether I'm going to do a rewrite or I'm going to iteratively replace, first thing I need to do is understand the domain and get test coverage around it.
Hmm.
You could do that first, and that is a low risk thing because whether you're going to do a rewrite or an iterative replace, you need to do it. Every test you write helps you understand. So every test you write reduces risk.
Right.
It's a test, so that doesn't really go into production. But assuming you merge your tests into the main branch, they add immediate value. Again, you haven't you've postponed the risky decision of a rewrite or a replace, and you're
Hmm.
doing work that is necessary for either one, and it adds value at every step of the way, and it actually reduces risk.
Gotcha. So other than thesis shipping is inherently less risky, is there anything else about his original comment about risk that you had thoughts on?
Um, yeah, I mean, I love the idea, or I totally get where he was coming from in terms of, oh, I'm going to do this project in a way to minimize risk, and why that makes such sense to developers. And if I'm going to pitch a project, oh, I'm going to, there's say 100 units of risk, I'm going to do this part right here, which only got 5 units of risk, and then there'll be much less risk left over. Right, like that sounds right, like it makes sense, but it's actually a super risky thing to do because you don't know if you're doing the right thing.
Hmm.
By going for minimum risk, you're also going, it will push you onto the path of minimal customer impact, which means you get minimal customer feedback. So minimal risk pushes you in a path towards minimal feedback loops, which means that anything that eventually comes up is going to be much, much later in the project, and it's going to be much, much harder to fix it. So if we were going to take a theoretical rewrite like Nozomi, where they were going to build the framework to send the emails, that's what they were doing first, and then they never got to the part where they actually sent the emails because the project got, well, they got a little bit, but they didn't get to the end. If at the end they discovered that there was no way to send the emails with the current framework, like in all the cases, they would have been very, very stuck. And this is something I've seen in other rewrites throughout my career, is you get like 95% of the way done, and then some thorny case that you thought was just ugly turns out to be completely incompatible with what you've done. And now you're like, oh, I'm 95% done. I only have this one little chunk left, which I thought I had the risk under was manageable, but this chunk isn't doable with what I've built. And I've seen many, many projects, and by many, many, I mean like 5. Projects take a long time. It's software. I've seen them stall. And this is where the things just start dragging, because you try and what eventually ends up happening is either you mangle your perfect framework so much that to beat it, to hammer this new functionality in.
Oh yeah, kind of ruin the original intent, the clean code of the new one. You just kind of shoehorn the rest of it in, the missing functionality. Yeah.
Yes, this is where at the end, when you're at that mad rush to the finish line, that's where the beautiful code then gets crunched and crumpled and becomes just like the original system.
Right. I think in one of our earlier podcasts, you mentioned it being like moving, where at the very end, first you're all organized, everything's in its own box. And at the very end, you have this miscellaneous box, and you're like, just throw it all in there. And then you pay somebody to ship it across the country, and then throw it away once you get there and unpack it.
That is a thing. And you know it's a thing at the time, which just makes it even more frustrating.
Right.
So yeah, it's like that, where you need to get it done. You don't know how to get this last bit into your beautiful framework. So you shove it in and hope that you'll fix it later.
So we know that the method they did was inherently risky because it was riding the coattails. Like each of the individual pieces they thought were prioritized were still riding the coattails of the overall risky decision of this rewrite to begin with. And as we've said in many episodes now, the thesis ship, or this term Jeffrey's come up with, is basically the concept of shipping iteratively.
Right.
The thesis we've used quite a few times here is the kind of appropriate way to break down pieces into smaller deliverables that can go out more quickly and be less risky overall. And so these themes we've touched on a few times. What other themes of risk are you considering for today?
That was my main one, was the ginormous, well, just that deciding to do a rewrite or an iterative release is a giant risk-filled decision that you kind of have to make up front. But you could kick the can down the road the way that we were talking about before, which is the work to understand the system, the work to being able to get yourself in a place where you could actually do a rewrite without having to go back and learn what you don't know, would enable you to chop a large percentage, probably half or more, of the project from the end and put it at the front. If you do that, it's not that you've de-risked it, because when you're going to go back and add testing around an untested and probably written in a way to make it untestable code base, you're going to cause outages. You're going to break things. Certainly there will be risk. Well, not that there will be outages. You'll break things.
Right.
But when you do that, you add value to the current system as well. And so the place where the split, right, between here's your original system, which is providing value, and you're like, oh, I'm going to do a rewrite and it's going to add this much more value. You can push that split further away and just add the value to the old system. while still getting an equal amount of value for the theoretical new system that you may or may not ever build.
Yeah, it seems like this iterative way of tackling anything really is, or the DC shipping is going to provide pretty much everything the company needs at that point. You're releasing code to production faster, so people always have this concept of like continuous deployment. So you're getting things out there today. The customer is seeing value because you're actually fixing. Like the reason your entire system is you want to rewrite to begin with is because you have all these issues and bugs. Or if you're fixing at least the ones that are the most prioritized, then the customer is seeing that value over time. You're actually making progress. And then by the time you do want to not rewrite, but extract some functionality, let's say, to a microservice or something that you know, like this doesn't really belong in this monolith here, then you've already gone through, nicely extracted some of these features, test covered them. By test covering them, you have characterization of everything your feature's doing. So at this point, it becomes super easy to see where the fracture point is. Like, oh, this is all of the features related to this product. There it is. We've already defined everything. Okay, if we want to split out part of that to make it more scalable, excellent. Let's extract some of this part.
Right. As an example, let's say you were a company that had a giant PHP monolith, and
never heard of it.
That never happens. Giant PHP monoliths, super rare. And you had a business decision, right? It's not, oh, this PHP monolith is unmaintainable and terrible, even though it is. But you're making the business decision of, hey, we can't find good PHP developers, but we could find Java developers. Java developers don't want to do PHP work. Shocking.
100%.
Yes.
Everyone I've met so far.
And so if you're looking at it from a business decision, saying, hey, we want to rewrite our system from PHP into Java because we can hire Java developers and we can't hire PHP developers, and our PHP code sucks, right? So it's like the plan is we're going to hire Java developers. The Java developers are going to rewrite everything from PHP to Java, and it'll be better because we'll have more better developers, and Java's better than PHP, so it won't have the same terrible qualities. At least it won't have the same monolithic PHP-driven terrible qualities. Okay. And so if that's like your plan, the decision to, like, that's a very risky plan, because the plan is we're going to hire people, they're going to rewrite things, and that rewrite is going to be successful.
Right.
If instead of that, executing on that specific plan, you start with the plan of, we want to do this. We want to rewrite everything, not because we hate PHP, but because we can't find developers. We have to get our current PHP developers to get us into a place where the Java developers, when we hire them, will be able to do the lift and shift out of the PHP, which means that you would have to have the PHP developers refactoring, writing tests. And lo and behold, by the time that everyone feels that they've got the code into a state where it's actually useful to hire the Java developers,
they fix the problems.
Well, they fix most of the problems. You still have the fundamental problem of it's hard to find good PHP developers.
True.
And so if they then still wanted to hire the Java developers and rewrite things in Java, they could do that. But now it's a much more direct thing because the Java developers can understand what the PHP is doing.
Yeah, it's almost like writing documentation, basically, for all of your features and all the code that you want to extract. Because we mentioned a few times now, no matter what, the decision to rewrite or to not rewrite, you still have to know what your product is. And you can know your product by going through and refactoring your current code and adding tests. And oftentimes that will iteratively deliver value and de-risk your product.
Yes. Sorry, I'm just having this flashback. I spent many years in finance. And one of the things that you have to learn in finance on a periodic basis is this thing called know your customer, which is it's anti-money laundering things. They basically have to teach you how money laundering works so that you can spot it if your customers are starting to money launder. So you have to,
Okay, yeah.
right? So it's like I've gotten lots of government mandated training on money laundering so that I can spot it if I see it.
And now the government's taught you how to launder money.
And now the government's taught me how to launder money, and what they're looking for so that I can avoid it.
Excellent.
It's good. Tax money well spent. And the idea that you need to know your system is something along the same lines of you need to know what your system is supposed to be doing so that you can know when there's red flags and what those red flags are kind of indicating to you,
right?
That are screaming like, oh, well, if I've got an import-export business, right, and they're wiring money and collecting money and then wire money, like that's normal. But if all of a sudden a big chunk of money comes in and they want to wire that money, like you notice the pattern. Those are the kinds of things where if you know your system, you'd be like, wait, this is a transformer, or like it's an ETL thing, and where data is going this way, all of a sudden some of the data is going back. Why is the data going backwards? Somebody's shoehorned the writer in with the reader or something, and it's like, oh, well, that's clearly wrong. I should break that up.
Right.
But bringing it backwards, it's when you do all this work. In this example of the PHP developers, all the work that they're doing to get things ready for the Java developers. And if you're ever going to do this, you also need to train your PHP developers in Java so that they know that they have a future at the company. All the work that they're doing to get things ready is valuable. And it adds value to the customers today, and it adds value to the project going forward.
Sounds right. Separately, I feel like I have heard many people just trash on PHP and say, oh, we have to move from PHP. We have to move to this other thing, whether it be Java or some other kind of Python in the back end or something else. But almost every time I've seen the code, it's not a PHP problem. It was never a PHP problem to begin with. People love to blame the language for their poor architecture decisions, but PHP can handle a fair amount before you really need to justify the amount of money spent to hire completely new developers, build a completely new technology, and extract everything to it. I think maybe it should be a little reflection on the current code before you do something like that.
Oh yeah, 100%. PHP lets you shoot yourself in the foot very easily, but if you're using the language correctly, it's not a bad language. For assuming that what you want to do is, CRUD-based web development or CRUD-based websites, then it's a perfectly fine language.
We just lost half our subscribers. Half of the few we have, Jeffrey.
Half of the few we have, we're down to 10 now. Let me keep going. But I've seen people running, oh, well, I'm going to run all of my cron jobs, which are going to do these massive database queries and data managing, and that's all going to run in PHP as well. It's like, well, no. PHP is a web language for, CRUD-based stuff. If your goal is to, get an incoming request, process the post or the put, update the database, and then return a response, which is a web page, PHP is fine. You will never, until you are Facebook, and Facebook rebuilt PHP to make it work for them. But like until you are at web scale, 1 million events a second, PHP is fine for displaying web CRUD. If you have, don't do your backend processes, if you've got big data or something, don't do that in PHP. That's, don't build your job scheduler in PHP.
Right. Yeah. I can definitely be on a soapbox on this topic, so I won't go too far into it. But yeah, every language
next week.
Yeah. Why PHP is fantastic, and they'll have like 0 listeners. Modern PHP has come a long way, guys.
Yeah. I don't know. I think we're starting to run ourselves in circles. Should we wrap it up, or is there any more points
I think we're good for today's episode?
All right, we pissed off the listeners, hopefully.
It's your fault the code's bad.
It's your fault. If the code is bad, look in the mirror and be like, you did this. Don't blame PHP. Don't rewrite.
Don't rewrite.
Yes. You can blame
Iteratively
PHP.
deliver
PHP
value.
is an inanimate object; it won't care.
Hmm.
But blaming it on the rain is more traditional. It's the canonical.
Ah, true, true. Anyway,
Thank you. Thank you for listening. I'm Jeffrey Sherman.
and I'm Isaac Askew, and this is Never Rewrite.